Our second talk is Andreas Oschlies, and I'm very pleased that he's going to talk to us about one of the other Ocean Decade programs, this one focused on oxygen. So Andreas, over to you.
There we are. So, all right. Yeah, thanks a lot for inviting me, and thanks for the great talk. Usually it's the other way around, that the exciting talk comes at the end, the great science talk. So this is about, do you see the right side of the slides? Yes. So this is about another UN Ocean Decade program called Global Ocean Oxygen Decade, and with the great acronym GOOD. So this has been put forward, it has emerged from the Global Ocean Oxygen Network, GON. That's an IOC UNESCO network, started about 5 years ago, focusing on deoxygenation and also low oxygen environments in the ocean. And in this talk, I would like to present you a little bit about, well, the history of this program and planned activities. It's still a very early phase, and we don't even have a dedicated seminar series as you have in JETZON. So very excited to learn more from you how you handle all this. And it's about dissolved oxygen in the ocean. So you know we have low oxygen environments, particularly in the eastern parts of the tropical oceans. And we have pretty good understanding now about over the oceanic inventory of oxygen. This is near surface waters, about when the thermocline a few hundred meters deep on an isopignal surface in the thermocline. And in the end, oxygen in the ocean is a tiny part of the oxygen atmosphere. So we really would not feel deoxygenation in our daily life as long as we don't eat seafood. And we live very close to the coast sometimes. But it's not really a problem for breathing air for us, for any land or terrestrial species. Nevertheless, we do care, and we should care about ocean oxygen. So one reason is coastal communities have report more and more low oxygen events. This might be related to the use of mobile phones, which is more and more, it's increasing, and people may have more time to walk along the beaches. So we have some evidence that at least there's a large number of these red dots on the map are reports of hypoxic events. And we occasionally see fish kills right here. Maybe even the emergence of jelly over ordinary top or fish as top predators, and also harms to benthic ecosystems, including coral reefs, also might or sometimes is related to low oxygen. So life in the ocean is affected by oxygen changes. And we know from historical observations, particularly in the open ocean, where we have a pretty good data coverage, that the ocean has lost about 2% of its oxygen inventory over the last 50 years. So this is quite substantial. It's one of the largest changes, actually, we may see in the environment. It might be the longest lasting change, anthropogenic change, the planet may endure over the next few centuries. So this is reason for some concern, the 2% decline over 50 years. If we extrapolate that, the ocean would be devoid of any oxygen in 2,500 years. So this is drastic and dramatic given the timescales we observe, timescales of change we observe here. So it's pretty much all over the world ocean, wherever we look. This is vertically integrated oxygen change. The red colors show a decline in oxygen. It's not uniform, and there's a surprisingly large change, well, estimated from observations. We still have data gaps there in the deep ocean. What do the models say? And this is still CMAP 5 here on my slide. CMAP 6 doesn't make a big difference here in global oxygen inventory changes. And models underestimate current models underestimate the observed or observational estimate of oxygen change, oxygen decline. For the last 50 years, about 0.6% in the CNEP5 models, and very similar in CNEP6. So it's a 2 to 3 times lower rate of deoxygenation by current IPCC type models. And despite, well, this is known for a few years now, and we and other groups have tried to improve models or bring models closer to observational estimates, and so far haven't had much success bringing both observational and model-based estimates in better agreement. Oxygen is closely related to carbon respiration, and therefore this might be a reason for some concern that maybe carbon uptake modeled by the ocean, by current climate models might have systematic deficiencies compared to observational estimates. Observational estimates of carbon uptake are not as robust as for oxygen because of the lower signal to noise ratio and shorter historical data set as well. Oxygen data are available, pretty accurate data for more than 100 years now. And so this is a maybe unique data set to confront models, climate models with, and help to better constrain these models. So this is about our starting point, where we started and thought it would be good to use the UN Ocean Decade to improve our understanding of oxygen changes in the ocean. This depends, of course, on data, particularly in coastal environments, which are not, they do exist, and also for over a long time series usually, but they are not widely openly available. They're usually in national waters, and sensitive issues are about, well, environmental practices or maybe sometimes even military usage. So this is something we have difficulties getting hold of and hold on. And so this is one main threat to improve the data availability and also the data collection best practices to measure oxygen and oxygen changes, and just use that as a great opportunity within the UN Ocean Decade to improve our data set and thereby eventually our understanding. The second objective is the co-design and development of measures that can mitigate drivers and impacts, or if this is not possible, provide appropriate adaptation measures for coastal communities, ecosystems that could be maybe managed in a way to protect them better against deoxygenation, but also coastal economies that may depend, on many cases in developing countries, particularly depend on seafood and the availability of oxygen in the water. So this is basically helping to ensure provision of these ecosystem services to society, to coastal communities. This is much what the UN Ocean Decade cares about, and we again use this opportunity, make people aware of a potential threat to their ecosystem services they depend on, but also use their knowledge, expertise to provide more information, collect more data, make these data available, and together find measures to mitigate and hopefully find solutions against ocean deoxygenation. The outcomes we expect from the program is first the increased knowledge base, causes, impacts, and threats of deoxygenation, so mechanistic understanding, and also better understand vulnerabilities of individual species, of ecosystems, and feedback cycles. There are a lot of biogeochemical feedbacks linked to different nutrients. Iron, nitrogen, phosphorus have all different interactions with oxygen and can lead to positive and negative feedbacks. Where understanding is lacking, this might explain part of the discrepancy between current models and observational estimates. So there's a perceived pretty large knowledge gap. And this will depend on an increased capacity to better measure, document, and monitor ocean deoxygenation. Related to that is the development of indicators, like there's metabolic indices for different species, and there's water quality issues that have been used widely in many coastal environments. And it would be one aim and hopefully an outcome of this program is a unified set of indicators that can be understood worldwide and can be understood easily by coastal communities and can lead to action. And that's the final outcome we hope we can achieve here, actionable strategies to mitigate and adapt to ocean deoxygenation on local scales together with stakeholders there, but also on global scales to minimize this currently perceived huge impact, anthropogenic impact on the Earth system, this oceanic oxygen loss, and help to reduce the human's footprint on this essential part of marine ecosystems. We have a small number of activities planned. None of these has really started. We are currently writing proposals and discussing with stakeholders, consultancies to get these activities off the ground. There's also a current call for more activities in the UN decade. And the first one is identifying and understanding threats. So this is individual species, ecosystems, population, communities, lethal effects, of course, but also sublethal effects. Even in not currently perceived low oxygen environments, there will be a decline, or is currently a decline of oxygen almost everywhere in the ocean, and it might matter. It does affect metabolic activities of essentially all species, and these far from lethal effects may have a huge impact on the structure and functioning of ecosystems, of marine ecosystems. And this understanding of these lethal and sublethal effects is essential to better define and eventually construct measures for mitigation adaptation. The link to water quality, so that has been recorded and worked on historically in many countries, many coastal societies. And we think there's a win-win situation to combine this and exchange information between these local, in most cases, local stakeholders and the worldwide scientific community to generate a uniform set of indicators, measures, and eventually use that to get access to more information from local stakeholders, get more data, convert data into a uniform system, and improve our understanding. There are also links to pollutants and also production of other greenhouse gases, nitrous oxide and methane particularly, which is very oxygen and redox sensitive. The third one is ecosystem services. So this is a very, very targeted stakeholder engagement process. So case studies and workshops in coastal communities, and particularly in low oxygen areas in the tropical oceans. That's where we want to start. To bring, well, to make people aware of potential problems, to build capacity to measure, to understand, and to act, to mitigate again, and if that's not possible, to adapt to envisage changes in oxygen. And here we really are currently reaching out with a few other programs to set up first, well, workshops and summer schools in a couple of coastal areas in the tropical oceans. Then we have a link to co-stressors. That's one of the communities of action in this ocean decade, so linking to ocean acidification, to warming, and generate synergies between different programs. Deoxygenation, of course, is not the only threat to many ecosystems, and we have to understand the combined synergetic and sometimes antagonistic effects of different stressors. One activity is centered on economic aspects. So this is basically, it's a worldwide connected fishery economy that has a huge impact even on coastal communities in remote places. And having a holistic understanding of these economic pressures that affect the ocean services and their sensitivity to changes, explanation is the part of this activity. It also includes strategies to raise funding for mitigation adaptation measures and links to other UN activities outside of the UN Ocean Decade. And then a scientific activity to just better understand the causes and also attributing any changes to anthropogenic and natural activities, natural processes. This is the core of activity 6, and hopefully we will then be able to deliver scientific presentations like the first one we've seen today in a few years' time. So this is, and there we are it's for us as scientists, it's easiest to make progress. So we are writing proposals in the EU and have links to the US science academies. And we expect that we can launch a few dedicated ocean oxygen programs and have a few calls out soon. And one activity currently already underway is to improve our mapping and modeling. This is not particularly the mapping one, to generate a global ocean oxygen atlas. We have such atlases already for at least the open ocean, the World Ocean Atlas. So far, we do not have a very good link to coastal areas, and we don't have a very good overview of our temporal changes. So here is something also probably linked with GLODAP and SOCAT, different atlases. So we are building in between all these currently established atlases, a new global ocean oxygen atlas. This should foster also motivate people to contribute their data, particularly the coastal data, which are not currently in international and transparent databases. So there is a huge set of data out there, but we have to make it public and easily accessible. Also, some issues about quality control, best practices, and so on, which are to be covered here. And then capacity building ocean literacy. So this is citizen concentrations are getting off the ground and close interaction with stakeholders, particularly in the tropical oceans and coastal areas. First successes was a paper, it's in review, it's not out yet, but about the Global Ocean Oxygen Database and the construction of the Oxygen Atlas. We link to currently 4 communities of practice. I'm not sure where JETZON is there. I think might be in all of these as well. We can maybe discuss that later. And we have a first a truly ongoing activity, which is first UN Decade activity, is a Global Ocean Oxygen Network webinar series. And this brings together during each seminar an early career scientist and a more senior scientist. It's particularly targeted to allow during COVID early career scientists to connect to the international community of more established scientists, but also to build their own network, become more visible, and basically allow the next generation of scientists we depend on to get established and build this capacity and expand it to allow successful work during this Global Ocean Oxygen Decade program. That's all from me for now. So thank you. And I very much look forward to move things forward together with these different programs, and I'm happy to discuss possible links to your program. And I look forward to this exchange and interaction with you. Thanks a lot.
Thank you, Andreas. As I have to say, that's very impressive. You've got a lot of, you've clearly given it a lot of thought, and a lot of activities coming through. So let me go to the chat. Have people got any questions that they would like to ask Andreas? Laurent, would you like to ask Andreas?
Yeah, thank you, Andreas, for your talk. I have a question. You say that the models underestimate the decrease of the oxygen, but what is the initial state? I mean, the models do they at the beginning of well, you understand my point is that do the models underestimate the initial content of oxygen at the beginning of your simulation, because it might change, it might play a role in the decrease?
Yes, that's a good point. Yeah, I didn't mention that. So many CMIP models underestimate the oceanic oxygen inventory quite substantially. It's up to 30%, and they're far too. Many models have far too large oxygen minimum zones, oxygen deficient zones, but also models that have a pretty good representation of oxygen patterns and inventory show very similarly slow decline. So this starting point does not seem to affect the decline very much. The starting point mostly is a result of too large oxygen deficient zones. And so in those regions, oxygen doesn't decline anyway. It's already basically zero. And it's more the deep ocean. The largest discrepancy are really in the waters below 1,200 meters, where most current models have very, very little oxygen decline, deoxygenation, but the observational estimates show a large, substantial decline there, which is difficult to explain. I think it's a circulation effect. Can't be, it's difficult to envisage biology playing a major role there. And these are areas where most models have still pretty good or realistic oxygen concentrations in most ocean basins, close to the deep water formation areas. So there are huge problems even in CMIP6 models getting oxygen right, the starting point right, but we don't see any trend that models that get a better description of the current state of the starting point have a better agreement with observed rates of oxygen decline.
Okay, thank you.
Thank you very much for that question, Laurent. Does anybody else have a question that they would like to come in with? I've got one related to that. I mean, I guess I had a sort of similar thought process to Laurent. I know it's difficult to tell at this stage, but you mentioned that you think there may be a circulation issue. I mean, do you have any feel for, what the contenders are, the potential processes which are giving this discrepancy between model and observations?
Yes, well, we have already unfortunately tested a few of these ideas, and all were wrong, apparently.
Right.
So, well, but there are a few left which we haven't tested. But overall, I think it's still, we see current models still tend to underestimate variability, interannual seasonal variability, even seasonal variability at Bermuda and Hawaii in the thermocline in terms of oxygen is underestimated by current models. Variability associated with El Nino and so is underestimated. And so it might just be that we have selected for the sluggish models. There's a natural selection pressure when models are being developed. So those models that behave well, are very maybe dissipative, and but still do perform well when you come back the next day and sit in front of your computer. Model is still running. So these are the nice models that have a high chance to survive, but more sensitive models that tend to evaporate the ocean overnight or freeze the ocean and are just more sensitive to any perturbations, they have a higher risk to go extinct. And I think the way we do science is selecting for models that underestimate variability in all variables probably. And if oxygen is particularly sensitive, as it seems to be with this 2% loss over 50 years, then we might see a larger underestimate there compared to other variables like carbon or even heat.
Yeah,
and we lack a few biochemical feedbacks in still most models, like the sediment interaction with phosphorus or iron. Even denitrification, nitrogen fixation is not well understood. Nitrogen fixation particularly is not well understood, which could have an impact. Well, certainly does have an impact.
Yeah.
But yeah, it's an interesting problem and a little bit embarrassing that we haven't understood it much better yet. But it's still pretty recent. Maybe it's well, less than 10 years old. So we still have good chance, I think, particularly for the next generation of scientists to resolve this issue.
Yeah, absolutely. I mean, well, you've got the decade at least, which is a good starting span. But I find it interesting that, you know, this perspective that we may be perhaps choosing less sensitive models over sensitive ones, and that may actually bias our results. I see Dave's got his hand up. Dave, do you want to answer the question?
Yeah. Just a question based upon Andreas. Thank you. Nice talk. Great idea. The oxygen budget puts a pretty tight constraint on how much carbon the oceans are sequestering. And that requires kind of an understanding of air-sea exchange and the respiration ratios, right? So are there thoughts about how to tie what's going to be going on in good to understand what sequestration is? First part of the question. And the second part of the question, do you think we could see anything that we do purposefully? For instance, in terms of carbon dioxide removal, for example, within these kind of data sets, and you know why I'm asking this.
Yes, I think oxygen might be a very good indicator for everything we do in terms of carbon dioxide or biotic carbon dioxide removal. So we have always this very high signal to noise ratio there. I think that could be, or I think it is very beneficial to look at oxygen there. It's easy to measure. Mm-hmm. It doesn't cost a lot, and there are a long time series. We have good observational records of the natural background, and so that might. I think it offers a lot of opportunities to detect anything we do with the ocean, and if addressing carbon, that might be even better. Carbon respiration, I think. Well, yes, I don't think we could see changes in the respiratory coefficients. So that's probably very difficult because the total amount of mass is so small, at least during one ocean decade. What I think is probably more important is changes in circulation that link to residence times. Mm-hmm. And that's what you, Dave, had in your recent paper about residence times, sequestration times. This is could change a lot, and even during 1 year, you could change residence times by a decade or so. So there are possibilities to amplify changes if we look at transit times or residence times. How do you call it in a transient ocean? Mm-hmm. And I think this is very exciting, but it's conceptually pretty difficult, at least for my brain. And I think we need clever people, clever ideas how to monitor this, or how to develop concepts that can really measure changes in sequestration times and ventilation times and transit times in the ocean. And this hopefully is one of the hypotheses that might help to bring observational estimates and model estimates closer together if we go away from the steady state, which most of current climate models may still have in the deep ocean because they are too dissipative, too viscous. And we lack many of these fast small-scale processes and can't resolve them maybe, but also have, the pressure to finish your PhD and probably goes in the direction to rather use a more viscous model that makes success on the PhD front usually faster.
Thank you, and thank you, Dave, for the question. Priscilla, you'd like to ask a question? Excellent.
Yeah, thank you. I was wondering what kind of mitigation strategies for ocean deoxygenation can actually be put in place locally.
Yes, there's one that has been tried particularly in lakes, but also in a few fjords, is just pumping air into the water. That's a brute force mechanism. It doesn't always work well. Sometimes it doesn't work at all. It has even adverse effect, even for oxygen. And there have been a few experiments, or field experiments doing that. From modeling exercises, we don't think it, it could work very locally, but it doesn't work on a larger scale, because in the end, you just pump warmer waters to deeper depths, greater depths, enhance respiration, enhance oxygen consumption, and also perturb nutrient cycles and everything. So other mitigation measures that are more promising from the studies that have been done so far, in my interpretation of these studies, is biology. So like seagrasses, macroalgae that all produce oxygen and can help putting more oxygen or producing more oxygen in the water, and also, at the same time, taking out carbon. So there are possible win-win situations. Other mitigation strategies, particularly in coastal environments, are just reducing fertilization. So that has been done in many environments in Europe or in the US. Sewage plants, fertilizer use in agriculture, but there's still pollution from by the air, so nitrous oxides, which all act to fertilize the ocean, to in the end increase oxygen consumption at depth. And this would be one fast mitigation measure, I think, to reduce nutrient input into the ocean. And the more difficult one, is then reduce warming. So in models we see when we reduce warming or stop CO2 emissions, then we stop surface warming. And so that can, in models at least, stop deoxygenation in the surface waters instantaneously. So that would be reaching the climate goals. Net zero emissions of CO2 would stop deoxygenation in the surface waters, but not in the deep ocean. There, even if we stop emissions today, according to our models, deoxygenation would increase, oxygen loss would increase by a factor of 4 at least. So only 1/4 has been realized, and we have 3/4 still in the pipeline of oxygen loss in the global ocean. And I don't see any way to mitigate that. So there are particularly deep ecosystems will have to adapt, and will suffer for a couple of 100 years. And this is one of the reasons why we think, or I particularly think, this might be the longest lasting problem that we currently produce on Earth, that we basically move a wave of low oxygen waters through the global ocean. And this wave is underway, and I don't see any way to stop that. We just have to make sure it doesn't become more intense, and we can mitigate the intensity of this wave.
Thank you. On that sobering thought, I think we should draw things to a close. So thank you very much to both our speakers, to Andreas and to Priscilla, and to everybody who could join us.